All righty. Well, we are now in the home stretch, everyone. We are almost there. So we're going to talk about Mod 10 today. What we're going to discuss today is going to be Mod 10. And what we're going to really look at is going to be the chapter 20 and 21. So that'll be what you're required to read. This is going to be in the previous chapters, Mod 9, you talked about just basic networking concepts and configuration, right? So in this one right here, what we're going to do is we're going to go ahead and talk about some of the actual more networking services. So we're going to talk about things such as like the web service or proxy and how to set those up. So what you're going to notice is that there's not going to be any projects for these last three modules, 10, 11, and 12. The main purpose for that is because you're going to go ahead and be working in your groups and you're on this one right here, the installation and configuring CentOS server. This is the group project. There will be a separate video talking about this, and I'm going to ask you, please go ahead and look at that. With that being said, everything, I will go ahead and post that on Mod 10. It'll be a separate video, and I'll send an announcement for that as well when that is up. It'll be up. I'll send it out today, probably more than likely. So, what I'm going to go ahead and suggest, I think you're going to have basically the whole rest of the actual week. There will not be anything for Mod 12. There will be a Mod 11 lab, and that'll be it. And I think that the actual final project is enough that it will go ahead and cover all your bases. And I'll show you how to go and access that in the module itself, in the explanation. All right, so let's get started. So we have a lecture we're talking about today. I'll talk about the lab. The lab is very simple. It's a very short lab. And you just have a quiz, okay? You just have a quiz. So let's go ahead and get started with the lecture. Let's go ahead and look at the lab real quick. So the lab, all you're going to be doing in this lab is you're going to be setting up the Apache web service. So let me let this load up. Dun, dun, dun. Come on now. I believe in you. Right, Mod 10 lab. So this one is going to go ahead. You're going to be so you're going to install and configure the HTTP web server package. You're going to go ahead and create a basic website. And then from there, you're going to go ahead and configure the log levels in the http.configuration file, and then the number of clients, okay? So you're going to limit the number of connections that you can handle. And I'll walk you through the entire process of doing that. And then up to the very end where you test out your actual website right here, okay? So that's going to be the lab. Then you do have a quiz, again, just like before, 20 multiple choice questions, open book, open note, you do you, get those easy points, okay? And like I said, we're at the home stretch. So, all right, let's get started with today's lecture. All right, so we talk about things such as today we're going to talk about DNS, which is domain naming service, okay? And the service that we have for this is going to be called Bind. Bind is the one that handles that in the Linux environment. We're going to talk about the domain host protocol. Excuse me, DHCP. And then we're going to talk about how to do email features. We're going to talk about Postfix. Postfix is going to be your email server. And then looking at Dovecot, which is another, and Procmail. So DNS is a protocol to provide name to IP resolution. So if you ever want to block your, like, let's say, for example, you don't want to turn off the internet, but you ever want to block the internet, you can go ahead, like from your kids, if they're misbehaving and you don't want them to have the internet and they're using the Wi-Fi, what you can do is you basically go ahead and turn off DNS on your router. Without DNS, you cannot talk to the internet. That is aside from port 80, which is HTTP and HTTPS, If you do not have DNS, you will not be able to communicate with the internet at all, okay? It is a part of the TCP/IP protocol. There are other protocols that can provide the same functionality, such as the Network Information System, or the NIS, or LDAP. So LDAP is going to be part of the LAMP system, right? So we have LAMP, LAMP for Linux, and this stands for Linux, Apache, MySQL, PHP, okay? So the Linux Apache, you can also go ahead and think about this is actually part of the lightweight LDAP, the lightweight direct access protocol, which is LDAP. You can configure the client to specify the DNS server. So you can actually go ahead and do that in etsyresolve.com. So I can go ahead and we'll talk about that. Let me see if we go into it a little bit more. And then that's basically how we go ahead and configure the DNS server. Some things should be a little bit more knowledge is that you have a host. For DNS terms, you have a host, you have a domain name, top level domain. FQDN stands for fully qualified domain name. You have subdomains, you have the naming server or NS. You have the authoritative naming server. That's going to go ahead and then you have zone files. You have records, you have caching name server, TTLs, DNS forwarders, forward lookup, reverse lookup, and bind, okay? So let's go ahead and talk about first of all how does DNS actually work? So when you serve to, like, for example, this website called onecoresource.com, the first thing that's going to happen is your computer is going to go ahead and try to determine that IP address of this domain. So it's going to determine this based off of the DNS server it can query. So in the etsyresolve.com file, which I'll pull that up right here, I'm going to go into them. I'm going to do a cat/etsy/resolve.com. Okay, it checks this file and it says, okay, who is my naming server and who can I send this query to? So my naming server, this is my IPv4 one. Here's my IPv6 one. So this is my DNS server in the organization, okay? So then what's going to happen is the local DNS server then says, all right, well, I don't have this information. It's going to request it to an external DNS server. This is going to be sent over to a root server, okay? The root server then sends a request to the DNS servers responsible for the .com domain. So it's going to keep moving backwards until the .com domain DNS server passes a request to the DNS server responsible for the onesource.com. And then it actually communicates that back to me, okay? This is called a DNS query. So if you actually do any type of actual web traffic or anything else, or you do any type of communication on your network, this is the first thing that is sent. And it's mainly going to be done through an ARP and then a DNS query, okay? The ARP will say, who has so-and-so? And then ARP will respond saying, I'm so-and-so. And this is my IP address. Okay, cool. Once that happens and it says, hey, web server, I want to know who this is. And like, all right, cool. Who is so-and-so? Who is onecoresource.com? The internet's going to say, hey, at the .com level, OneSource course actually is this. And say, hey, that's me. And then from there, I think they're going to start communicating. Okay. So we can actually look at bind by going to the etsynamed.com file. So let's go ahead and actually look at that. Oh, okay, cool. So that means I don't have that in there. So if I need to, I can go ahead and do a sudo yum install named and see if it picks it up. Let's do bind. There we go. Right, so we're installing bind. Primary configuration file for the bind server is named.conf. Now let's go ahead and go into there. Change netc and let's do a cat of named.conf. Oh, sudo. Okay, sorry. So here's the named.conf file, okay? This is for the DNS bind service, okay? It's read by the bind server called named. And that's actually the daemon or the service that actually reads this file when it's first started. Then the allow query setting. This setting is in etsy name.d.conf, so we can actually look for this. We'll do allow. We're going to do a search for allow. Let's go ahead and actually go into the named.conf file, right? Permissions. So let's go ahead and sudo that. There we go. Now let's look for allow. There it is, the allow query. This setting is in the Etsy and it limits which systems can query your DNS server. So basically right now it's set to localhost. So only my local machine can query the DNS server, okay? You can do logging settings. We can set the logging settings here. Let's go ahead and let's look for logging. So here's the logging settings here. There's the zone settings right here. So zone files are going to be very important because you're going to be dealing with zone transfers. And bind and DNS are kind of a very unique protocol because they both operate on a UDP and a TCP connection. TCP being there, and the operating port, if you remember from the module 9, is 53. So most DNS actual requests are sent over UDP. A zone transfer, which you may go ahead and actually look at that, or again introduce that in another course, is transferred from one part of the network to another. Okay, and this is done via TCP because you don't want any packets to go ahead and actually drop. Okay, then you also have the include setting, so we can actually look for the include setting. Let's look for that. So let's go ahead and look for the include setting right there. Here's the include setting. Okay, so we have the include setting, and this enables us to place additional DNS settings in a separate file. So these are like the separate files right here. Here's a separate file for zone and the root key. Okay. Again, so we talked about this right here being the zone files. And then let's go ahead and go into var/named. Let's do. Let's look for named. Okay, so that is the directory. So we have to be root to go into there. So let's do this. Sudo ls named. Okay, here we go. So these are zone files to define the hosting to IP address translations. And this is going to be there are two zone files by default, the list of root servers. So let's go ahead and actually do a cat. We're going to do a sudo cat named /name.ca. Okay, so here's the root information. And notice it says dig right there. We have some information here, sudo section. We have the answer section right here for the root servers and the root server IP addresses. There's A records and there's quad A. A records are for IPv4 addresses, quad A for IPv6 addresses, okay? And let's look for the localhost one. named.localhost. There's our localhost one right there, okay? And this defines the localhost. We have the loopback address, which is going to be a single A, and then the ::1 is the quad A, okay? And this is the server of authority right here, okay? So this is actually going to be the zone files. So zone file entries, you can use zone files. You must first make entries in etsynamed.conf. So let's go back into that real quick. We're going to look for zone. Okay, there it is right there. If the changes to zone are created on the local machine, you typically set up another DNS server containing a copy of the zone files mastered via a zone transfer. Okay, and this is what we're talking about. So you can also do what's called, we have a forward lookup and a reverse lookup, and think of it this way. So a reverse lookup, query provides an IP address and the DNS server returns a domain name. Okay. So here's the so to create a reverse lookup zone, you can add an entry like this. We have the zone. Here's the IP address right here, and then here's gonna be the file. Okay, and that's gonna be the domain name. So we have that information right there. We also like there's specific syntax we have to follow when we're creating zone files. Best to copy an existing one. Don't try to modify it. Don't try to go ahead and create it yourself. Don't recreate the wheel and make more work for you, because you actually will miss something or it needs to be set a certain way. Make sure you comment lines begin with a semicolon, continue to the end of the line. Each line defines a record, and in most cases, the end of the line is the end of the record. Each record consists of fields of data separated by spaces or tabs, so make sure you keep an eye on that. And the fields are defined as name, TTL, record, class, record type, and record data, okay? When we're talking about the syntax zone files, you're gonna notice that the @ character means that the current origin, that's the current domain, okay, if there's an @ symbol. The $TTL setting, that sets the default time to live, or TTL. When times are given, the default time value is in seconds, okay? So this is actually going to be 86,400 seconds. So that's the time to live for that. So there's actually a couple, when we talked about like records, we said A record and quad A. Was actually is more than that. There's a bunch of different records. There's a start of authority or record. This defines the authoritative information about the zone. And basically this can be seen as operating instructions. Then you also, the address record type, this defines a domain name to IP address translation. And then there's a canonical name, which is going to be the one domain name to translate to a single IP. There's also, these are going to be called A records, okay? There's a NS record, which is called the name server record type. And this defines the name servers. There could be more than one. There's also a mail record, surprising enough. If you have a mail server, you can create what's called an MX record. And this actually queries the domain name server from MX records, or basically mail servers. It'll actually relate the IP address of the mail server to the domain, to the actual host name of that mail server, okay? And there's another thing called pointer records. Pointer records actually are used in reverse lookups to translate IP addresses into domains, okay? So we usually go ahead and do the opposite, which is domain name to IP addresses. That's what that's for. So what we can do is, you know, make sure when we look at this, we don't want to make it too complex and too convoluted. Look at the sample files and modify it as needed. And then look at log files when things do not work. So really go into var log messages and see if there's anything. There actually probably, let me go ahead, I haven't looked at this before, and I wouldn't doubt that there isn't one. So let's go ahead and do change directory to var to log ls. And more than likely, there's going to be a log in there for probably in messages, okay? Probably messages is going to be one of them. Or maybe an audit. So, and then there's also examples in your book on page 333 and 335. So you can also set up what's called a slave bind server. This requires additional steps in the COMD, which is going to be for the slave server. So let's go back to that real quick. Slave, doesn't mention that, okay. So you may have to go ahead and figure out what needs to be added into the actual text document for slave to actually be a thing. And basically this is like, you know, slave server as an NS record on the master server zone file, and you have to modify that on the end, and you can test it. There's ways you can test that actual DNS setup. So let's go ahead and actually look at this and see. So we do named check configuration verifies the syntax of the name.d.conf file. So we can do a named tac check zone. And that should go ahead and zone name and then file name. So we're going to do /etc/named.conf. Let me check and see. All right, so apologies, I was actually typing in the wrong command. So we do and I need to be root for this. I'm gonna do sudo named tac check configuration. Now the cool thing about this is that if there's actually no problems with the configuration, then it'll go ahead and actually give me no result. But let's go ahead and see what happens. So let's go ahead and do this. Let's go, I'm gonna do a sudo vim /etc/named.conf, okay? Let's just go ahead and just for kicks and giggles, let's see what happens if we comment this out. Okay, it didn't have any problems. So let's go ahead and let's uncomment that. And let's break this. I'm just trying to break it just to see what happens. All right, there we go. So we know that there actually is an error there. All right, we're good to go. Okay, cool. So we can also check the zones too, the syntax of specific zone files. And remember, those are in var log name D or var name D. Right. So we can go ahead and do that. We can also use a command called dig. Dig actually gives us a lot of output in the same format as the zone file. So let's go ahead and do a dig of, you know, .google.com at localhost. And let's see what that, if that gives us anything. It's probably not. Let's just do a dig at So here's a dig for google.com, okay? Or let's do a dig for localhost. So here's a dig for google.com. So it did a DNS query. Here's the A record. It's on this IP address here. And this is my server, okay? When was it done? What's the message size? It's 59. This is we got one query, one answer, no authorities, and one additional, okay? So we have the information there. Let's look at the localhost. Localhost is the same thing. We got a authority. We got one additional, one answer, one query. Okay. So we got that, and this is how long it took. 1 millisecond. This one took 1 millisecond. Okay. So we can also, purpose of a chroot jail is we can do what's called a jail for bind as well. This limits access to the system file. So you want a chroot command. So it changes the root of the file system for a process and places the bind configuration files into a specific subdirectory, and then starts the named process so it appears that the root is that subdirectory. So this is actually kind of important. So you can actually move stuff around with that bind. You can create the chroot directory. You can see that on page 338 to 339 and configure the named to start in jail. So that's where you can go ahead and actually edit it that way. Okay. You can also split bind D and do a DNS. You can do two options, DNS view or use two DNS servers. You can do transaction signatures. This limits the likelihood of DNS cache poisoning. And this is really important because that's actually a technique that most actual attackers will use to actually do that. What they'll say is that, hey, I'm your DNS server. And they may either throw up a secondary one, or they can go ahead and throw up a rogue one and say, hey, I'm actually the DNS server. Come look at me. And then what you'll do is you'll poison their ARP cache with the actual routing to their location instead. Okay. So you can do that with DNSSEC keygen commands and sign zone commands. When we talk about dynamic host configuration protocol, this is the DHCP. This is what handles the actual the leasing out of IP addresses on a network. And this is configured in DHCP server. We're not going to walk through how to do this or anything, but I don't have that installed. But what we can do is we can install it. And I cannot find it. There we go. DHCP server. Okay. Again, it creates the actual log. It's going to be a DHCPD. So we go ahead and do a sudo vim /etc/dhcpd.conf. Okay. Nothing there. But if we actually installed that correctly, we would be able to see it in there. This is this is go through an example of how this works. Optional routers, you have the subnet mask, you have the NIS domain. You also have time offset, the NTP server, network time protocol server, which is very important. Configuring static host, you can also have a static host as well. DHCP log files are going to be found both in daemon.log or in messages, depending if it's a Red Hat distribution or a Debian distribution. We also can configure SMTP, which is going to be the mail user agent, the submission agent, transfer agent, deliver agent. So we're going to go ahead and do sudo yum install SMTP. We're going to look at that one. So this is actually how, if you ever wondered how an email actually works, this is really good to understand. You have the user agent, which is going to be POP and IMAP. IMAP is more the more common one that's being used now. We don't really use POP3 anymore. There are POP2 and POP1. So the way it works is that you can use your application to send the email. That's going to be the user agent, okay? It then sends it to the MSA, which is going to go ahead and be the submission agent. This is going to be things like SendMail, Postfix, and then from there it goes to the MTA, which is a transfer agent, which is going to be SendMail and Postfix as well. And then the MTA, it goes to another MTA, then it goes to another MTA, then it goes to the MDA, which is going to be the delivery agent. So how's it going to be delivered? It's going to be proc mail, mail drop. Then it goes to the mail spool, which is going to be var spool, and then the user 2. And then it hits POP or IMAP, which is going to be given through dovecot on the Linux background. And then it goes ahead and goes back to the agent, okay? So we can actually go ahead and install Postfix. We can do sudo yum install Postfix. This is going to go ahead and the modern SMTP server. So you can actually go ahead and see that we can edit the configuration file there. So we can do sudo vim /etc/postfix /main.cf. This is the configuration file for Postfix. If you want to go ahead and edit it, you're more than welcome to. We're not going to do that here, but just know that you can install Postfix by that way. You can manage local email delivery with procmail. So you can go ahead and look at procmail. So we can do a sudo yum install procmail. It may tell me it's already installed. It's not installed, but you can use that for local mail, okay? You can use it to block spam, redirect mail to other user accounts, so you can do forwarding. And then you can make copies of messages, send to other accounts. This actually is called by the MTA. And the procmail package is installed by default on most distros and is often enabled for Postfix and SendMail. Notice for us it wasn't installed, okay? So you have the :0 tells procmail that is in the start of a new rule, and you can set up flags for procmail rules and how to handle it. So you have the capital H, the B, the D, the lowercase c, lowercase w, and capital W. You can also lock files, a file name or a character. You have condition lines, you have procmail utilities, and here's an example. Sort all mail messages sent to Bob, okay? And place them in the Bob file directory, okay? Another example matches any messages from the support that contain reboot in subject line. Send a copy to this email address here, and store that message in the mail directory support reboot directory, okay? So you can see from support, okay? Subject has the term reboot in it, so it doesn't matter what's before it as long as it has reboot in it, okay? I want you to go ahead and make a copy of it and send it to this address here, and then also do send this out to store it in support.attack reboot, okay?
You know, the inbox format is the traditional standard format used by MTAs. You know, typically everything on mail is stored in a file, in a flat file, and you can actually scour it through VAR spooled mail. When a new message is sent to the MTA to that user, MTA locks the VAR spooled mail while it's actually appending the message to that document, because it's basically a long-range document. You can then also have users can search all their messages using a utility called grep, which we've used before in the past. You have the mail dir format. This actually is what's created when they want to receive mail. It has two subdirectories, new, current, and temp. This is considered faster than the previous one. If you know the grep command well, you can also use this to store it because it stores as a flat file. Then you have IMAP and POP. You have both allow an MUA to request access to mail messages. And you have the Dovecot server. This is an MDA, okay, for most distribution, and it supports both POP and IMAP and mail dir inbox. And you can configure it under Dovecot. You do have to install it. It's not by default. You can see clean configuration by writing the Dovecot -n, and then you can see examples of that on 359 and 362. Okay, and that is it for chapter 20. We're going to talk about chapter 21, which is going to be Apache servers. You can configure Apache web server, enable security features on a web server, and then set up a proxy. So you have the Apache HTTP, which is commonly known as Apache or Apache web server, and it's sometimes referred to, you hear the term HTTPD. That normally is the name of the web server process. All right, so Apache, like I said before, is the HTTPD server, and this comes back to the word of the week. So the actual attendance verification word is going to be Apache, A-P-A-C-H-E. One of the cool things about the Apache service is going to go ahead and be that basically, you know, at the end of the day and everything, it's very simple setup, and you'll see that in the lab. So the Apache service configuration file is httpd.conf, okay, or it's called Apache 2 in Ubuntu. So if you ever have that, you can see it like this for CentOS or Red Hat distros, or for Ubuntu distros and Debian distros, you'll see it like this, Apache 2. So the configuration file, let's go ahead and install it real quick. So I'm going to do a sudo yum install Apache. Let's see if it finds it. Nope. Okay, so we're just going to do HTTPD. All right, and this is everything's going to install. So we're going to hit yes, and let's install it. So now we can actually do a sudo vim /etsu/httpd dot. Let's see. Let's go back real quick. And /conf. So here's the conf file right here. And let's go into the httpd.conf file. So here's the the conf file that we're talking about, the server root one. And here's some directives. Everything, you know, the server root is going to be HTTPD. It's going to be listening. So here's the root server right there. It listens on this port right here, which is port 80. Okay. For this one, I think it's going to be set up to the local host, which is going to be your loopback address 127.0.0.1. So we don't have that filled in. This is where the root document's going to be, where you can serve documents. This is how you can actually view stuff. So in the actual activity, you'll actually set this up under the var www.html. And this is going to be log levels, so you can actually control different log levels. So there are some actual cases where we do have directives that require multiple values, and the syntax for that multiple value line is going to be very similar to HTML. Okay, you can see right here, very much similar. Okay, if you have multiple lines, so you can start the Apache service. It's going to be called HTTPD. So first, let's go ahead and enable it. So we use systemctl a patch. We can do HTTPD enable HTTPD. You can see right here, it's enabled. We can get a status of it too. Right now, you can see right here, it's not running. It's loaded though. It's not active. It's not running right now, but it is enabled. So that's actually a good thing. Okay. So what we're gonna do now is let's actually go ahead, instead of enabling it, let's go ahead and actually start it now. And then we'll get a status. Now we have it running. Okay, so now it's running in the background. And if we were going ahead and actually look at our processes, we should be able to see, it's not gonna be there. So let's do a PS AUX. So you see Apache right there. Okay. And you'll learn more about PSAUX a little bit later in one of the later chapters. So that's how we can actually test it. We can test it by everything. Test the server by creating a small text file. So we can go to, we're going to go into the var HTML. So let's go ahead and actually do that. Okay. And then once we're in there, we're going to go ahead and touch a file. We're going to touch this and call it test. So I need to be root to do that. And then I'm going to go in there and just do testing. We're going to do test, insert testing, 1, 2, 3, testing. I'll save it. Okay. And then if I was to go ahead and actually browse to this document, I can go open up a browser. And it's listening. I can go ahead and if I want, remember it's listing on my local host, so 127.0.0.1 on port 80. Sorry, that was a previous file. Okay, and that's how we can do it there. Technically, I think I should go ahead and let me just do this just to see if it actually fixes it. So I'm going to restart the service real quick. I'm going to do a sudo system ctl restart httpd. Sorry, I know it seems like I'm doing a lot and everything, but I just want to make sure it actually looks like it's supposed to. So we can go to 127.0.0.1 on port 80. Server's up. What we can do is we can actually do this. We're going to do var HTML or var /HTML / test.html. And there's our actual file right there. And that's what we have inputted there. So in the exercise and everything, you'll create this and you'll go ahead and be able to see it live once you set everything up. So you have some looser logs, access logs will contain information about the attempts. We can actually go, so we're going to do the var log, and let's do an ls tag l. And you're going to see that there are HTTP log. So we're going to go into there and root to do this, and then we can do an ls. I don't know why it's not letting me in. Right, let's do this. ls tag l. So here we go. Here are the access logs, and here are the error logs. So we want to go ahead and actually do a cat of these and look and see what they are doing. So you can see right here, here's the GET requests, okay, that I just did today. And you have error logs. Oh, here are the error information, okay? So we have that information there to us to help with that. We can also enable PHP. Remember, we need that for LAMP. You have to install it though, and we're not going to do that. We're not going to install Perl, but you know, Apache usually works with PHP and Perl. Those are scripting languages. And then you know, you have web server security. Make sure you limit the number of user accounts in the system, which you can do that in the conf file. You can also install minimum software required for the system to function correctly. So you don't have to install all these other avenues. If you're not going to use PHP or Perl, don't install them. Limit which processes are running. So make sure that only the processes that need to be running are running. Secure the critical directories. Again, you know, very similar to the bind jail. Make sure that you can't go ahead and get access to it if you don't need to. And make sure you implement a firewall. Remember, firewalls are very important. You can limit the amount of client access in the primary configure in http.conf, okay? You can have the number of clients that connect, so you only support to 150 clients. Be mindful though, so when they say it supports 150 clients, I mean the 150 connections, okay? Unique connections. What that means is that once you reach 151, basically, they won't be able to actually go to that server. It'll just constantly be waiting for, you know how you, if you're like, for example, if you're waiting in line to buy tickets on Ticketmaster, they're only able to support so many actual connections. You can limit the access to specific directories on public web server too by setting authentication methods, and that's going to be in the conf file. You can also make sure that module authentication is enabled. You can also create a password file, which httpassword command, and this actually limits that too and sets that password. You can also, there are two places to configure security for specific directories. You have the var HTML secure, or you can create a file named .htaccess, okay? You also have virtual hosts, and these are hosting more than one website on a single physical machine. So you can do that with Apache. You can do this through IP-based virtual host. So each web domain has a separate IP address, or you can do name-based virtual host. So all domains share a single IP address. So you have many to many, or you have a one to many situation here. Okay. This stuff right here, you know, you can also do this in the Apache web server file. Again, this is a little bit more advanced. We're not going to talk about it too much, but you can set that up in the configuration file. You can also have HTTPS in there too. So if you want to use 443 instead of you know, where you're instead of using 480 for HTTP, you can the technique used by SSL is called asymmetric. It's public key cryptography. So two keys are used in this case. So you have a public key and a private key, whereas the private key is unknown and the public key is known. So you sign stuff with your public key in most cases to encrypt the data sent to the server, and then because there is both a public and private key, it is asymmetric, and what the key is provided to all systems upon request, and then you decrypt it with your private key, okay? The symmetric cryptography is the same key. So that's why it's asymmetric is two keys, symmetric is one key. So you have an SSL authentication. This kind of just goes through the process. So you press the public key, receive the request, and then they send the public key to you. You receive the public key, then you request verification from the certificate authority. That's going to be a way we check the hash of the key and make sure this is a legitimate key. So sometimes regardless to website or anything, you may have gotten an error message saying that this actual certificate is actually invalid. That's what they're referring to. The certificate authority does not actually verify this is the legitimate key. Okay. You can have SSL issues, but the large number of CA machine decreases the chances that one could be compromised. You compromise the certificate authority, you own the keys to the kingdom. Your web browser must blindly trust the CA in some cases. And that's actually a scary thing too. So you're basically saying, hey, I trust that this actually is legitimate. This also leaves you susceptible to man-in-the-middle attacks. With virtual host, the client does not include the name of the website when requesting the public key, so the server doesn't know which digital signature to send the client. So that's another problem with SSL and Apache. You can implement that several ways with the mod SSL. So you can do that in the load module section. And then you have to set up a server, an SSL certificate to do that with the CA. So it's be digitally assigned by a certificate authority for that to work. So I'm not going to go into too much detail on this because it is actually a more advanced setup and everything. But this is actually to set up Apache. And then we have a proxy server. Proxy server is a system that facilitates communication. So normally everything you have, for the way it's set up, you have a proxy, you have your firewall, you have a proxy server, and you have web server. And then you have the intranet. So if you have clients on the intranet, and I'm not saying internet, the intranet, INTRANET, that are making web requests, they will go first to the web server. The web server will then send it to the proxy server. The proxy servers then will see if the proxy server has the website that you're requesting, it'll send it to the web server and say, hey, here it is. If not, the proxy server is the one that actually goes and gets it. So it's actually kind of like it does forwarding on behalf of the requests. And there's three different kinds. There's a tunneling, forward, and reverse. So tunneling is a gateway between two networks. So you have when IPv6 to V4 tunneling. So you can actually have an IPv4 to V6 and V6 to V4 tunnel. And that's what a tunneling proxy is for. You have the forwarding proxy, and this works on the client side. This is what we were talking about earlier. And most people mean when they call a system a proxy server, web browser can point to a proxy server instead of communicating directly with the server itself. So you point to a proxy server, and the proxy server handles the communication between that and the web server, okay? And then you have, there are some advantages. The proxy server can act as a filter. You can do filtration, you can do application filtration. You can hide the original client data because then when it's happening, when the proxy server is handling the request, it strips off the client data and puts its own data on it, on the encapsulation and sends it out. And then when it gets it, it's like, oh, who had this? And it's like, oh, I need to send this to client A. Okay, cool. So let me go ahead and readdress this to client A. It can also, proxy server can cache static data. So that's what I was talking about where, if I'm going to google.com, it's like, oh, client A and B already requested google.com, and I already have an updated cache of that actual website. So here's google.com for you. And also you can help use it to log client activity, which is very important if you're trying to make sure that people are using if you have an acceptable use policy and trying to make sure that people are using the actual system like they're supposed to. And then you have a reverse proxy. This is configured on the server side, whereas the forwarding proxy is configured on the client side. Instead of having web clients connect to your company server, you have to connect to the proxy server initially, and the proxy server then communicates with the web server. So that's the way it's set up there. You have the client comes to the internet, connects to the reverse proxy, and it hits the server system in that case. And usually, typically, they are all going to be in things such as what's called the demilitarized zone or the DMZ, okay? So there's some advantages to this. The proxy server can send queries to multiple web servers, so it allows you to do load balancing. It can limit the load from the server by caching static data, just like the previous one. The proxy server can perform SSL-based operations. The proxy server can effectively hide the web server for the client, making the web server more secure. So you can actually hide the web server, and it can optimize communication by compressing the data. So proxy can compress data. Another thing that you're going to hear about a lot is something called Squid. Squid is a very common proxy server that's used in the Linux environment, okay? And you can configure it to do access control lists. You can have, it has built-in ones. You can also use the Nginx one, and this can act both as a proxy server and a web server. So Nginx actually is kind of a combined effort in that case. It does have some actual benefits as well, very similar to Squid and other proxy servers. So that's just basically, again, I didn't go into too much detail because one, a little bit more advanced with setting up all this stuff. But for references and everything, you need to understand the concept that these actually can be the thing. So that's it right there. Please go ahead and just make sure, enjoy the rest of your week. Please make sure you watch the mod 10 about the project. And then if you have any questions throughout the project, email me. Don't just assume that you're going to go ahead. And if you want to make sure that you're doing this correctly or you're having problems, email me, especially because the project is kind of lengthy. I will not lie. It is actually, that's why I'm giving you all 4 weeks and you're not really having any type of projects. You're going to be working on the project, the final project, which is hands-on. And you're going to be working on one server for that one. All right. Well, if you have any questions, please email me. If not, have a good rest of your week. Again, just remember the attendance verification is Apache. So if you didn't get that from the lecture and everything else, that's fine. If not, then you'll have a great day.